Hey everyone, my name is Sally and I'm a senior product manager here at Arise. Today we're going to be doing a paper reading for judging the judges, so evaluating the alignment and vulnerabilities in LLMs as a judges. With me today I have Julia. You want to give an intro to our group here?
Yeah, I'm Julia. I'm also a product manager at Arise, focusing on the LLM observability component. And I've been here for a few months now. This is my first paper reading, so really excited to dive in.
Yeah, I think this is a really great one. And paper actually, I think you found and you searched to the group. So I think it's really great. So with that, we'll jump into it. As we go through the paper, we'd love these to be interactive. So feel free to drop us messages or questions in the chat or the Q&A. We'll be monitoring it and answering questions as we go, and we'll try to save some time at the end to answer questions as well. All right, so for today's agenda, we're going to start off by just giving a little bit of an introduction to LLM-as-a-judge, just in case anybody's not familiar with it. Then we'll go through the experimental setup of this paper, and then we'll finish off with an analysis, the results, and just the practical takeaways. Cool. So I feel like LLM-as-a-judge is definitely a popular topic today in the generative AI space. In case anybody here is not familiar with it, LLM-as-a-judge is a way to kind of evaluate your LLM's responses using, another LLM. So the real problem with evaluating an LLM is that trying to do human evaluation is expensive, it's time confusing, and it's just all around impractical. You can imagine you have a system running and trying to get a human evaluator to kind of sit there, read through all of the text, because a lot of times these are generating lots of text, read through it and decide whether or not it's correct. It's just going to be very time consuming. So the idea is to have this second LLM, oftentimes the same LLM or maybe a different one, smaller version perhaps, evaluate the responses. And this will often be through binary labels. That's a practice that we at Arise believe in, is using these binary labels like good or bad or incorrect, correct, to evaluate whether or not. So oftentimes there's a prompt, like we have here as an example of one where we're maybe giving it the text, and then we're determining whether or not it's toxic. So this is actually a toxic eval that we're doing here. We do have a ton of examples in Arise if you're curious. We have a whole kind of evaluation package through Phoenix, and so you can take a look there and look at some examples that we have built. But of course, you can always do like a custom judge too. Julia, anything you want to add here? Anything that I might have missed?
Yeah, I think that covers it really well. Yeah, just going to add that we do just have all these examples over here in this library, and it's very versatile. You can do hallucinations, summarization, toxicity eval. There's even like SQL generation eval. So it's just a very versatile method that we use a lot at Arise.
Totally. And basically, if you're curious like what those packages, it's really the prompt that changes there, and you're just going to pass that to whatever LM you want to use. But those are some really great examples if you're wanting to get started. All right, cool. So now we understand what LLM-as-a-judge is. Again, the whole premise of this paper, you can see here, the goal is to evaluate the strengths and weaknesses of LLM-as-a-judge. So there's a lot of talk on the effectiveness of this or exploring different methods of doing this. This paper really wants to understand, like, what are the strengths, what are the weaknesses of using this approach? And so what they use as their data set to do this is the TriviaQA benchmark. So it's about 400 examples from 95,000 QA pairs sourced from 14 trivia and quiz leak websites. So on the side here, we have an example where you can see you have a question and answer, and there's also an excerpt that's kind of like reference text. You can think of it that way, that contains information on how to answer. So they actually chose the clean examples where the interhuman agreement is high, so that like 96% range. And so they're going to use this as the basis. And we're going to talk a little bit more about the different types of models they use and how they set up the experiment. But kind of the cornerstone, if you will, of this experiment is this TriviaQA benchmark. This is what we're going to have our task be on and what we'll have ultimately the LLM-judge judge on. Cool, Julia, I have a question for you. Something that I thought was curious. Is there a choice to only use this, TriviaQA benchmark? I see the pros, right? Because it's like just a classic, question answering data set. It's kind of got a nice variety to it. It also has these excerpts in it, but curious what your thoughts on this choice of data set is.
Yeah, I thought it was interesting. I mean, first of all, they chose a much older data set. This is from 2017, back when LLMs weren't as powerful as we have
Yeah.
today, like GPT. So it's a much simpler problem. And the focus there, I think, originally when they made this data set was just being able to extract the right information from the excerpt. So they, include this excerpt when using these exam taker models, and see if they can extract, like for this first example, that the guns of Navarone is the relevant part of this excerpt to answer the question. But then for this, they're actually kind of like changing the task a bit and focusing just on open-ended questions and answers for these judge LLMs without the, it's like extracting that information from the excerpt, which is interesting.
Yeah, I agree. It's an interesting setup here, interesting data set. I totally agree. That was my first kind of thought when I started looking into the data set. I was like, this is kind of old.
Yeah.
So it's also that kind of conversation we have of like the biasy towards what the model's been kind of trained on. I wonder too, like how that impacted this experiment too, choosing a data set that is so old. But yeah, just a little antidote there. Yeah, so this is a template. We're going to get into it in a slide or two, but basically there are exam taker models. These are the models that they're actually going to have execute this task of answering these Q&A questions. So this is a template. So we're kind of translating that example we saw on the last slide to this template here. And so you can see it's giving, questions and answers that the LM is to choose from essentially. All right. It's a little bit more on the setup. So again, as I just mentioned, we have exam taker models that are going to generate answers to the trivia questions. We have the LLM-judge models that will label those question answer pairs as correct or incorrect. And then something they did is they have this idea of a baseline, and there are a few different ways that they establish this baseline. So there's exact match. So you can think of this as like, was the two answers, is there an exact match across them? There's contains, and you can kind of think of that as like an overlap type of metric of like, is there, similar words that are contained in the answer? And then of course, the gold standard human labels of, correct or incorrect. So that's how they're going to establish their baseline. And then for measuring alignment between judge models and humans, there's a few different metrics they use. I think the two main ones, and they do kind of like a delta between them, is percent alignment and the Cohen's Kappa. So we'll go into a little bit more detail of what those are. I don't know. I had never really had that much experience with like Cohen's Kappa, for example, before reading this paper. So we do a little bit of an introduction, so y'all will have some context on that. And then here's the template for a judge. So you can kind of see that this is pretty similar. I think Julie and I have some notes on how we think this prompt could be optimized, but you can see this is pretty similar to that one that we showed you on the first slide, that example from Arise, where we're saying, okay, your task is to look at the question, and then based on the reference provided, determine if it's correct or incorrect. So this is just sort of like labeling judge model here. Julia, any comments on, the approach or anything I might have missed for the alignment metrics?
Yeah, no, I think that was great. And I just want to comment, if you look at this prompt template for judge models, you can see how simple the task is. Like it really is a much more simple task than most tasks we see for LLMs today, where,
Yeah.
this reference that the LLM judge is looking at, it basically exactly matches the model response, just, in capital letters instead of various casing.
Yeah, and it's interesting. It's in there twice too, so I think that's really problematic if we want to just like its ability to just discern there. But yeah, that's a good call out. We just got a question from somebody else. They asked why it's in there twice. I don't actually recall if the paper mentioned why they include the reference twice, or if that's just like an artifact from the data set. Julie, do you remember reading anything about that?
Yeah, I think there's usually multiple references from different annotators. So I think every question will probably have multiple references.
That makes sense. Yeah. So it's just in there because, multiple references, and it doesn't sound like they're filtering out any repetitive information there, just kind of propagating it through. That makes sense. Didn't catch that detail. Cool. And then the last part of the setup is, of course, understanding what are exam taker models, what are our judge models. So exam takers, they actually have kind of two versions of models that they often use. So we have the pre-trained base model, as well as an instruction tuned chat model. So you'll see them call it base or chat throughout the paper. And so that's what it's referring to, either the pre-trained version or the instruction tuned version. They did try to use a wide range of model sizes, which I think is really important, and it comes up in some of their takeaways, how this impacted things. And then the prompts for the exam taker models contained 5 few shot examples. So they are using few shot here for the exam takers. For the judges, they actually stuck to exclusively the instruction tune versions. And there's also a wide range of model sizes. So again, I think that's important that they included that on both sides of things. And then of course they were instructed to respond only with the correct or incorrect, a very common best practice when using LM as a judge. And if you're curious down there, that's like just the full list of models they used. Again, they have the exam taker and the judge. And there's a nice kind of, I think, range of there between different types of models, different model providers. I personally feel like there's a few that I would like to see added to this list. I know we just had the release of 4.0, which was definitely after this paper was completed. And I also think like, some of the Claude models would be cool to see in here too. So that would just be one note I had. But overall, I think this is a pretty comprehensive list of models here.
I also thought it was interesting that they're using a lot of the same models for the exam taker models and the judge models. Because
Yeah.
I do know that there's other papers that talk a little bit about self-bias in models. So like
Mhm.
a GPT judge model might prefer outputs from GPT models. But I guess in this case where it's such a simple task of just responding with a single, answer, often just like one or two words, I think in this case that probably isn't an issue.
Totally. And that's kind of the impression I got is they made a call out to it even in the paper. It's like they tried to create this controlled environment, but I think in doing so, they kind of oversaw some of those nuance, like what you're talking about with like that bias. And so I totally agree. Like I would love to see some more. And when we get into the results, y'all will see kind of they do some kind of overlap, but they don't specifically really call out, okay, like let's do Llama 2 specifically with, Gemma or Mistral or GPT-4. There is that overlap. That's a really great call out, Julia. Cool. So as promised, here's a little bit more in-depth information on the alignment metrics. So first off, we have the delta score. So this is the difference between the score assigned by the LM and the human judgment. So you can imagine a positive delta score means there's the LM scored higher than the human judgment. And then the negative delta score indicates a lower score by the LM. So this is kind of a comparison. I think this is one of the like easiest to grok in terms of like alignment. When they talk about alignment, I think this is another important point. Alignment for them is really between the LM as a judge and the human evaluator. If you've read some other papers, that can mean a little bit of a different thing. So just as we talk about alignment, that is specifically what this paper is talking about. Then you have a percent agreement, and this is the percentage of instances where the LM judgment agreed with the human judgment. And then Cohen's Kappa, a statistical measure that accounts for the agreement occurring by chance. So we have these visuals over here. Actually, Julia, I feel like you did a lot more research on this here. You want to explain these visuals to folks just so they can understand what that Kappa means?
Yeah, sure. So the idea here is that you have two different raters, rater one and rater two. And let's say the smiley face is correct and the frowny faces, they label it incorrect. So you can see the percentage of times on the right in this equation where they're just basically both labeling it the same way due to chance. And that's what gets you PE. So here it's like for rater one, 25 out of the 50 ratings, they just like statistically like half of those ratings are going to be the correct score, and then half are going to be incorrect. And then it's slightly different for rater two. There you have 23 out of the 50 ratings are correct, 27 out of 50 are incorrect. So just like using those numbers, you can calculate the probability that those two raters agree just due to random chance. And then you use that as PE over here on the bottom equation. And then PO is just the observed agreement. So that would be the 17 and the 19. Those values where they're actually just agreeing because they chose the same answers.
That makes a lot of sense there. So yeah, that bottom is the full calculation for Kappa. So whenever we reference that in the following slides, that's what we're talking about. And then they did call out that, Kappa score is more reliable than the simple percent agreement, especially when dealing with categorical data. That makes a lot of sense to me. I think anytime you try to kind of abstract too much away from an assessment, you kind of lose again that nuance. So I think that it makes complete sense to me. And I think we touch on this a little bit more on exactly kind of breaking down why the Kappa score is more reliable. Cool. So we'll start talking through some results. This first one here is actually specific to the exam takers. So just some call out that the base models outperform chat models. think this is important just for, anybody here who's kind of setting up some tasks here that, using the base models might actually be the better choice. So it seems that their explanations were that the chat models have a worse understanding of the particular prompt format, which is tuned more to fit, the base models, and that the chat models have, unlearned some of their alignment or some knowledge during their alignment training. So we have some graphs here. You kind of see, I won't spend too much time because I think that the real point of this paper is talking about judge models, but we felt like it was important to call this out. So you can see just looking at that first, this is just Llama 2. And you can see the difference between, the base and the chat. And it's kind of tricky. This is actually the y-axis here is the number of incorrect answers. So it looks maybe sneaky that chat is right, but it's actually that's a higher number of incorrect. And that's for incorrect entity, underspecified, too many entities. So it's doing it across a few different axes here.
Yeah, and one interesting thing, yeah, it's just interesting to think about when it's more appropriate to use like base models versus chat models, and to kind of keep in mind that a lot of chat models are designed to be better at either doing specific tasks or having a more conversational style. And I think in this case, since the task is just like answering a question with a few words and not in a conversational style, ideally, I think that's also why the chat models tend to be performing worse in this task.
That makes a lot of sense. Really great call out there. Okay, so I think personally, like this is one of my key takeaways from the paper. I could give or take all of the other information in there, but this is like I think one of the key things, which is that only the best models are good judges. So of the 9 LLM judges, only GPT-4 Turbo and Llama 3 70B showed very high alignment with humans. So again, alignment is that concept of how much overlap there is with the human judgment, and you can see kind of on that visual there that honestly, GPT-4 is not too far behind human. We call it here that it's 12 points behind. And I think Julia, we were chatting about this earlier, that you can see that percent agreement is kind of really close. So it is way more aligned than maybe one might think. And you can kind of see, Gemma, smaller models here not performing as well. Mistral's kind of in the middle there, and then we have our Llama models shortly after GPT-4. So what we would commonly think of as our best models are ones that they feel are best fit to be judges.
Yeah, looking
Anything?
at figure 1A on the left, you can definitely see that like the red dots of GPT-4, they're pretty much perfectly matching up with the human scores that are in black
Yeah.
for across all the different exam taker models, which is really interesting. Whereas like if you look at like Gemma 2B, like the scores are just all over the place. They don't correlate with the human very well at all.
Yeah, totally. All right, so this is kind of what we were talking about earlier. Kappa score is better than percent alignment. So this visual here, you can see we have percent agreement, and then we have the Cohen's Kappa. You can see there's kind of these vertical colorizations as well as coloring of the points. I'm calling this out only because Julie and I, it took us a little while to understand exactly what they were trying to tell us with this chart. So each of those points, they are colored by the judges, and then they're actually each point represents one of the exam taker models. So the Cohen's Kappa distinguishes judges better than percent alignment. So again, just has that better ability to distinguish. For percent agreement, there are deviations up to 20 points in the evaluation scores for similar Kappa alignment. And the scores aligned, or even the best judges models can differ up to 10 points with human assessments or human assigned scores. So I think the kind of TLDR here is like, if you're going to perform any kind of assessment on your LLM judge, you're probably going to want to use the Kappa score. It just gives you a little bit better understanding of exactly how well your judge is doing compared to like your human evaluator. I think that's the main point I take away. But Julia, any other thoughts you want to add here?
Yeah, totally agree there. And they even kind of give this threshold that they recommend where it's like a kappa above 0.8 shows that it's very well correlated and aligned with humans. And they do these little like vertical slices. So this vertical slice where they have like that near perfect alignment in blue, you can see a lot of the GPT-4 judges are falling in that category. And then that delta score, it's in a fairly narrow range around 0, which kind of shows the alignment. And you don't get that same, you get a much wider vertical range if you look at the percentage agreement chart on figure 1A on the left.
Yeah, I think it's just way even like it's way easier to like discern on the covenants agreement, like really the differences between models, as you're saying, like it's all kind of smushed together. It might almost appear that like, oh, any of these models does like fairly well with that agreement, but when you really break it down using Cohen's Kappa, like you called out that near perfect agreement slice, and then you have kind of all of these slices, it just is a much, I think, better way to understand their performance for sure. Cool. All right, so for this visual here, I think another one of their key takeaways is that LLM judges align well with human rankings. So the judge models may not assign identical scores as the humans, but they are aligned in ranking the exam model taker. So this is where they're ranking, again, which of those models is, I guess, better. And so the judge models struggle to distinguish between poor performing exam taker models. I thought that was kind of interesting. That was like, it was hard. It maybe could get the best ones, but then when it got to kind of those worst ones, it struggled a little bit to be like exactly which one was truly the worst. And you can kind of see that, I think, with like the zigzag of that bottom set. And then contains demonstrates the highest alignment with the human ranking. So swamping them ranks of only 2 of the 9 models there. So again, contains is just kind of that. It's not a strict exact match, but it's more of like that overlap of like, is there some overlap between the responses there?
I think
So
this also demonstrates again just like how much of a toy problem this is.
yeah,
Because like in the real world, if you're using judge LLMs, like contains is not going to perform better than any of the judge LLMs for like a task like, evaluating toxicity, right? Like it just isn't capable of doing that. So I think, yeah, the fact that contains is doing so well in this setting just means that we really are in a toy setting.
totally. When I first read that they were doing like exact matching contains, I just was like, exactly what you're saying. It's like you wouldn't use that in most settings unless it was, a generative, I guess some kind of generative task where you were trying to compare like a gold truth answer or something like that, gold standard answer. So I definitely agree that is definitely evidence of a toy environment here.
Yeah. So I'm just going to walk through a few more of these. So one common problem that they were seeing that I think has come up in other papers as well is position bias. This actually goes back to the references that were mentioned earlier. So here we're looking at an example of like what the prompt was that was fed into the judge LLM. And we can see in these 2 different cases, the references, which are the annotated human answers, are in 2 different orders. And the model response is Granite City. In one case, Granite City is at the bottom and it says the Granite City at the top. And then the judge says that this is incorrect because the reference order is in such a way that the Granite City is at the bottom. Whereas in the other case, the matching answer, Granite City, is at the top and then the judge output is correct. So just changing the position of the references when feeding this to the judge LLM actually changes the judge's output. And an interesting takeaway here is this tends to happen more if you're moving like the judge is more likely to identify the correct answer if the reference is at the top of the list than at the bottom. And this is also only an issue with the smaller models. So larger models don't get confused by this, like GPT-4 doesn't usually get confused by this, but for the small models, in this case, Llama 2 7B, it is getting confused by these cases. Anything to add, Sally?
No, I think this was interesting. I think you hit on the most important part here is just the larger versus small. I think that was something that was really interesting and perhaps something to kind of keep in mind as we think about the smaller models for evaluation tasks, specifically, I guess, how we structure their prompts.
Yeah, this is sort of adding on to it. It's kind of like explaining why we're observing this in small models. And I think the authors of the paper kind of hypothesize that small models just ignore the reference and they'll oftentimes just kind of use internal knowledge. So here's an example where the question is, the oldest known American cocktail, what whiskey forms the base of the cocktail known as Sazerac? And then there's a bunch of references that mention rye, but then for this smaller model, then it thinks that the correct answer is bourbon whiskey because it's just using its own internalized knowledge rather than looking at the references. So it just kind of fails to capture all the information in the prompt. Another interesting thing, and I think this has come up in other papers as well, is that LLM judges have a leniency bias. So there's a few definitions on the left. So there's this value PC, which is that the judge assigns the correct judgment with a probability of PC. And then there's this other value P positive, which is the judge assigns the rest of the samples to be correct with just this probability P positive. And in the appendix, they're able to actually do these calculations. It's quite long, so I'm not going to go into how they're deriving those numbers. But as you can see here, like, so for P positive, we would expect that just to be 0.5. Like, we wouldn't expect any bias, basically. So it should assign randomly whether or not the samples are correct versus incorrect. But here we're actually seeing that it tends to be above 0.5. So for like, especially for the small models, for Gemma 2B, we have a value of 0.8. For GPT-4 Turbo, it's not as extreme. It goes down to 0.66. But in general, the judge models just tend to be lenient and tend to agree with the exam taker output. Anything to add, Salian?
Yeah, I think this is one of the interesting points. I personally would be curious. Like we looked at that prompt at the very beginning. It's a very basic prompt. I wonder if there's some things we can do, like just with prompting of like prompting it, like if you're unsure, like, respond negatively, and that might not also be good, but I definitely think there's some implications of this, especially like if you're using this, to evaluate your LLM. So I think this is something definitely to consider, but I would be curious to kind of even see some, future research on like what maybe the best way is to overcome this and how different approaches help.
Yeah, I remember also like when I was going through the appendix, like they have the prompt that they gave to the humans. And I did notice that it's much more detailed than the prompt
Yes.
that they give to the judge models. And they're kind of telling the humans how to handle cases where it's like partially correct or other sorts of issues, whereas like they don't give that information to the judge. So I definitely agree with you that that could kind of account for some of the leniency bias.
Totally. And I think that's something you and I talked about a lot is just like some of the prompting. I think they gave the LLM very little. And I always say with a prompt, like if you can't expect a human to understand what you wanted to do with your prompt, the LLM is totally not going to get it. So that's a really excellent call out that like, okay, they're giving so much information, such a detailed instruction to the humans, but they just choose not to do that for the LLM judges. So yeah, good call out.
So they also did some analysis on the types of errors that the LM judges were making. And it seemed that LM judges are better at error recall than precision. And it also depends on the size of the model. So here on the top right, we can see how the performance in terms of like Kappa alignment in black, how it just kind of linearly improving as we increase the model size from like Gemma 2B over to the best performing model, GPT-4. And then for precision, that line in blue, for recall, the line in blue, it's also following a similar trend, where as we increase the model size, we also are getting that better performance and alignment with respect to humans. But then for precision, it's just kind of this flat line and kind of random. So that doesn't seem to be improving. And we can see that the correlation coefficient over here is like 0.0003, and precision is just not well correlated with human alignment. And a lot of this is related to false positives, where we falsely label the correct examples as incorrect. And that just seems to be happening across the board. Whereas false negatives, where we falsely label incorrect examples as correct, that seems to be like we're able to drive that down by improving the model and moving towards a larger, better model like GPT-4.
Yeah. I think this is another one of those areas where it's like I'd love to see some research on like maybe how we can improve this to, better handle these situations.
Yeah, totally agree. And we also noticed that judges failed to recall underspecified error types specifically. So here they actually asked the humans to annotate the types of error codes. So in this example, there's a question that is excluding Lady Jane Grey, who were the 5 monarchs of the House of Tudor. And then there's supposed to be this list of 5 answers: Henry, Edward, Mary, and Elizabeth. And there's different types of ways that the models can get this wrong. So it could be that there's an incorrect entity. So the response refers to a wrong entity. That's like the first example on the top. And we're seeing that like judge models like GPT-4 are really good at recalling this. But then when it comes to things like underspecified answers, so here they're listing Edward, but they're failing to say it's like Edward the Fourth. When they have these underspecified answers, then that's when the models tend to be more lenient. And even though they should be saying that this is incorrect, they tend to label it as correct. And it is a really tricky case, right? Like, again, like the humans were prompted to actually be able to label this as an incorrect answer if it's underspecified with some examples. The rest of the judges didn't receive that information in most cases. But it's these underspecified answers particularly that we see that the judge LLMs are struggling with the most. Anything to add, Salian?
No, I think you covered everything there.
And then the last thing we want to discuss is the sensitivity to prompt guidelines. So that's something we brought up a few times. And in one experiment, they actually did experiment with feeding in different guidelines to the judge LLMs. So we have these guidelines over here, which is without guidelines. I mean, it's not without guidelines, but it's just much simpler. And you can see the prompt right here. This is the prompt we were looking at before, which is kind of like 2 sentences explaining what the task is, and then the question, the references, and the model response. And then they also do have an example of more detailed guidelines that they gave the LLM. So here they're actually explaining in 4 steps what to do in different types of edge cases. For example, given the model response, only consider the parts of the response answering the question and ignore any extra text. And then in this last prompt, it's guidelines with examples. So here they actually explicitly mention underspecified answers. So the example here is December versus December 20. If the model only says December instead of December 20, which is correct, then it should be marked as incorrect. So they do experiment with different types of prompts in this last experiment. And yeah, the results are interesting because it seems like the bigger models like GPT-4, they are benefiting from those extra guidelines and the extra detail. Whereas the smaller models, they actually get confused by the additional detail in those prompts. So that's just an interesting takeaway that it really depends, like the prompting style really depends on the model that you're working with.
Totally. I think that's something that like I would have loved to see them again, maybe expand on even how they did this, how they determined what guidelines they used to even establish their prompts. Because something like that we know that is talked about a lot is that like, yeah, different models respond differently to different sets of instructions, different prompting techniques. Like, you know, if anybody here is building an application, if you switch your model out, most of your prompts are going to end up breaking. So it would be interesting to kind of see that kind of indexed on, I guess, a little bit more and maybe giving a little bit more specialized instruction based off of the model type, because that's just a nuance of how these models work. The same prompt just doesn't work for the same or for different models across the board. Cool. Yeah, I guess for some of the takeaways, I think my takeaway still after reading this and, you know, reading, other papers and even just seeing and practice, I still feel like LLM-as-a-judge is the best way to evaluate your model, even if there's that small discrepancies in alignment. It's going to have a high success rate. You know, we saw it was like 84% versus 94% or like 97%, and that's still pretty high, and it's going to save a ton of time and money. I'm still not going to want to have to read through all of my LLM's responses and try to judge them by eye or just by reading through them. So I think the LLM-as-a-judge is still the best way to go. I did think that, again, one of the key takeaways from this paper is that using best-in-class models is going to be your best bet for using an LLM as a judge. And then I wanted to make a call out that, you know, there are a lot of research papers out there that you can actually improve alignment by doing things like using assertions or criteria, and some of the things that like Julie and I talked about today. So I do think that's worth calling out that while they took a very, I guess they tried to be very clear with their experiment setup and try to make sure that they had a good controlled environment. I think there's some things that you can do just in a more practical sense that will improve that alignment. And then just some follow-ups that I'd like to see. Like we now have 4.0, we have 4.0 mini. Like how does that do here? I think we personally have seen like a lot of great success with 4.0 mini. Like it's been doing really awesome with eval. So I would love to see some testing there. I'd love to see different testing for prompts for different models. Again, I've experienced this. You know, we just recently released our Copilot, our AI assistant. consistent. And, you know, I ran into the issue of like, we swapped out 4 for 4.0 and it broke everything. And that's in the same kind of model family. Like as you work with different models, and something I'm actually trying to solve for right now is just like, when you have these variety of models from different providers, like the prompts need to be different. And so I'd love to see more testing around that. And I'd like to just see more prompt optimization. I think there's some stuff they could do there to kind of improve the performance of those judges. But yeah, Julia, let's hear what yours are.
Yeah, my takeaways are honestly quite similar. I mean, the first one is prefer large models as LLM judges. So they were looking at GPT-4 Turbo and Llama 370B specifically and showing that those had really good alignment. But yeah, maybe we shouldn't be saying large models, but just the top performing models, since 4.0 Mini, like you're saying, is also really good. And it's a smaller model that might actually perform just as well if we were to test it. And then, yeah, if you're using a smaller model, I thought it's interesting that in that case, you might want to prefer shorter prompts, whereas for larger models, having the more detailed instructions will always help. And then the other thing about evaluating LLM judges, I did think it was interesting to start looking at Kappa score instead of percent alignment, which is what I think most people would do by default. So I think it would be interesting to start using that metric some more. And then also in terms of prompt optimization, I definitely think, if we're seeing that LLM judges do have this issue around underspecified answers, then I think it's probably helpful to specifically in the prompt explain how to handle those types of edge cases to kind of avoid that failure mode. I'm not sure if it would totally resolve it, but it might be that if you just give the LLM judge those specific instructions to mark underspecified answers as incorrect, then that wouldn't be a problem. And then, yeah, the last thing I just want to note is that this is definitely a toy setting. Like, I feel like, in practice, we wouldn't be using LLM-as-a-judge for this type of use case. We'd probably use it more for something like toxicity eval or hallucinations. So because of that, we don't know if these takeaways from this paper necessarily will scale to those other use cases that we see in practice. So it's kind of important to try this again on your own data and, take the takeaways with a grain of salt.
Totally. Yeah, I think that's another thing I forgot to add there is like, I definitely like to see more like ambiguous and open-end tasks be tested here, because you're absolutely right. Like this toy setting, it's hard for us to kind of take this and translate it to what we're doing in the real world or in production setting. So I totally agree. Love to see that.
Yeah.
Cool. Well, that's the end of the reading. I think we can do a call for questions. Again, either in the chat or the Q&A. We're happy to spend some time answering them. We'll give folks a few minutes to submit any questions they may have. Going once. Yeah. We can share some more information on the Kappa score there. Julie, you want to pull back up that slide there?
Yeah. One sec.
We can just go over the metric calculation
Yeah.
again. So I think it's really just a statistical measure that accounts for the agreement occurring by chance. So I think that's like one of the main takeaways there. So again, we have this kind of visual here. And so we have, two graders, if you will, and they have the smiley face, sad face, as Julie explained. It's like basically correct or incorrect. And so what they're doing is first taking just that probability by chance. And so that's what that PE is going to be. So they're looking at like where their agreement was, and just doing this kind of statistical measure there. And so the top is kind of illustrating where that PE comes from, and then the Kappa calculation is below there. So we're taking the observed agreement, we're subtracting that expected agreement by chance, and then just doing that statistical calculation. But Julia, anything? I tried to do my best. You explained it, I think, better the first time.
No, I think that explained it really clearly. And I guess one idea that I'm kind of seeing in this is that each rater may kind of have their own bias, and so like this rater labels it as correct 25 out of 50 times, whereas the other rater labels it correct 23 out of 50 times. And we just kind of assume like this is just the natural inclination of these raters, and then by chance, the probability that they both label it as correct is just 25 out of 50 times 23 out of 50. And that's, you do it for both correct and incorrect, and then you get that just probability that they agree in general. Yeah.
Yeah, and Iman, you got it right there. So it's a comparison to random grading. It's and to answer the other question we have there is like, do other evaluation metrics take into that agreement by chance? Not really. You can see like percent agreement, as Julia mentioned, is probably the most common way to kind of assess like human versus judge, and that's just simply looking at like how much overlap there is. How many times did the LLM agree with what the human said? And I think we see that a lot when we're reading and seeing, you know, content being put out about, you know, like LLM as a judge versus human evaluators. And so I think that the Cohen's Kappa, that's why it's so promising. That's why this paper really asserts that that's the way to go, because there is this kind of assessment of, you know, random grading that is important if you're really going to objectively assess the performance here.
I would add that it didn't make too much of a difference. So it's like going back to, like, even though it's a key point of the paper, like if you look here, like the percentage agreement, other than these first examples, Gemma 2B versus exact match, the trends are the same between percentage agreement and Kappa scores. Like, you know, humans have the highest agreement and also the highest Kappa scores. And then, you know, as you go down to GPT-4 and worse models, you just see those same trends between the two.
Yeah, that's a really great call out. So I guess we can kind of take away that chance, the random grading chance might not have as big as of an impact there as you might think. Cool. Guess one more last call for questions. Cool.
Cool.
Well, thanks everybody for joining. And we'll see you next time.